Hello friends, welcome to VEDA Gate Academy. This is SIVARAM. In the last session, we have discussed about how to simply apply Mason's gain formula to a block diagrams as well as signal flow graphs. So in this session, we would like to see some special cases where generally the students may have a doubt or they simply do some kind of mistakes. Let me directly start with our next question. Okay, right. So this is one important question or category of question what we have to see. Okay, so in this particular question, once if you understand this question, we can understand how to apply Mason's gain formula for different category of problems. Let us try to consider this given signal flow graph. In this signal flow graph, what they are asking is they ask you to determine first one. Okay, N1 here this is R of S is input node because it is having, if you sit over here, okay, it is having only outgoing branches. So R of S is a input node and I can say C of S is a output node because it is having only incoming branches. But in the exam, what they are asking is, rather than asking you to determine simply C of S by R of S, rather than asking you to determine simply C of S by R of S, the first question what they are asking is, they ask you to determine the ratio of N1 by R of S. Okay, N1 by R of S. Here, what is N1? This node. Okay, this is the node of our interest. We need to determine the ratio of N1 by R of S. Now, according to the statement of Mason's gain formula, if you clearly focus on the previous session, okay, in the starting session, okay, in the starting class or starting duration of the previous session, what I have given is, I have given the formula where they have mentioned that it is the ratio between output to input. Output node to input node. But if you observe in this question, N1 by R of S, can I say R of S is input node? Yes, because it is having only outgoing branches. So I can say R of S is input node IN. But what about N1, guys? Can I say N1 is a output node? No. Why N1 is not output node? Because it is having both incoming as well as outgoing. Both incoming. These are incoming. These two are outgoing branches. Since it is having both incoming and outgoing, it is treated as a mixed node. But Mason's gain formula we cannot directly apply between mixed node to input node. But there are some properties in the signal flow graph. While discussing the terminology in the regular classes, we are giving some standard conclusions. From that conclusion, I would like to give the same statement over here. So the statement is, any mixed node, okay, be careful, okay, any mixed node can be converted as output node. Any mixed node can be converted as output node by adding one outgoing branch with unity gain. Again, I am repeating. Any mixed node is possible to convert as output node. And the procedure to convert a mixed node as output node is you have to add one outgoing branch with unity gain. So that means, for suppose if I want to convert this mixed node N1 as a output node, what I have to do is I need to add one outgoing branch with unity gain or unity transmittance. Now, the same 1 into N1 will be amplified and the signal that is available at this node is N1 again. For suppose if I want to convert this some node as, this is also a mixed node. Why? Because it is having incoming, outgoing, incoming, outgoing, right? So it is having incoming as well as outgoing. This is also a mixed node. Now, if I want to convert this mixed node as output node, simply add one outgoing branch with unity gain. For suppose if this node is A, the same signal A will be coming over here also. Am I correct? So this is first point you have to remember. Any mixed node can be converted as output node by adding one outgoing branch with unity gain. But we cannot convert mixed node as input node. This point also very important. Please make a note of that. Okay, we cannot convert a mixed node as input node, but we can convert mixed node as output node. Now, the point why I am discussing this one is, let me erase this. This is not required. Okay, here in the question they ask you to determine the ratio of N1 by R of S. And since N1 is a mixed node, but according to the properties, I can convert this mixed node as output node. So since there is a possibility of converting mixed node as output node, I can comfortably even apply Mason's gain formula between mixed node to input node. So the point you have to understand at this instant is, we can apply Mason's gain formula between output to input node as well as mixed node to input node also. Are you following what I am conveying? Right. So you can apply the same thing over here, then you will get the answer. For suppose, okay, here if I am asking you, tell me what is N1 by R of S. N1 by R of S. So if I am trying to determine N1 by R of S, now can you tell me how many forward pass are there for this one? So here, let me erase this. There is no need of this particular thing, right? So let me erase this. Yeah. What is N1 by R of S? Here, what you have to do is, you need to start from R of S and see how many ways you can reach N1. So N1 by R of S, for identifying number of forward pass, you need to identify first a number of forward pass. For identifying number of forward pass, you have to see how many ways you can reach N1 from R of S. That means you need to identify the forward path between the two nodes of our interest. What are the two nodes of our interest in this question? The two nodes of our interest is N1 and R of S. So you have to determine the number of forward paths between N1 and R of S. So now, can you tell me how many ways you can reach N1 from R of S? Only one way, guys. So this is the only one way. You may have a doubt that I can move in this fashion. After reaching here, I can move in this way and I can reach in this way. Is it a forward path? No. Why it is not a forward path? Because, okay, if I am starting from here, after reaching here, the node N1 is touching once. Again, if you move in this fashion, again N1 is touching twice. So, but while forming the forward path, all the nodes you have to touch only once. So, it is not a forward path. Right. Let me remove this. Yeah. So, this is the only forward path what you are going to get in this question. What is the gain of this forward path, guys? G1, P1 into some delta 1 divided by delta. Divided by what, guys? Delta. Now, for determining delta, here, most of the students, they may have a confusion that, do I need to even identify the number of loops between N1 and R of S, or do I need to identify the number of loops for the entire system? So, if you observe the definition of loop, loop is a closure path where starting and terminating node must be same. But if you observe the definition of forward path, it is a path from input node to output node of our interest. Here, our interest is to determine the forward path between N1 and R of S. That is the reason we have seen the number of forward paths between R of S and N1. Whereas there is no restriction for the definition of loop that you have to calculate or identify the number of loops between the two nodes where we are calculating transfer function. Okay, there is no such kind of restriction. So the point what I want to convey here is, irrespective of whether you are calculating the transfer function between any two nodes of our interest, always identify the loops for the entire system. That means whether you are interested to determine the transfer function between C to R or N1 to R or N1 to N2 or N2 to R of S, irrespective of the transfer function between any two nodes of our interest, always you have to determine the loops for the entire system. Okay, so here from this discussion, what we can understand. So since if you observe here, delta involves the determination of all the loops. It may be individual loops or two non-touching or three non-touching. But as we have discussed now, that the loops will be calculated for the entire system. That means, can I say a delta for a given system will be remains same. Delta for a given system will be remains same whether you are calculating transfer function between any two nodes of our interest. That means it may be between C to R or N1 to R or N2 to R or N2 to N1. Irrespective of the transfer function between any two nodes of a given signal flow graph, the delta will be remain same. That means the delta for N1 by R of S or C by R of S or N2 by R of S will be the same. So simply I will write delta. So what is the value of delta, guys, here? So you need to identify the loops. Can you tell me quickly how many loops you are going to get for this given signal flow graph? You can start from any node. Okay, if you start from this point, I can travel in this way and I can come back to the same node in this fashion. This becomes loop L1. Whereas if you start from here, I can move in this way and I can come back to the same node in this fashion, loop L2. And will I get any more loops? So let me try this one also. This is also a loop L3. Now, will I get any more loops apart from these three what I have drawn here? Yes. You are going to get one more loop. What is that loop, guys? If you start from here, I can move in this fashion. Can I move in this way? No, but I can try to travel in this direction and finally reach this one. This becomes loop L4. Now, I can quickly tell you what are the loop gains here. L1. Can you tell me what is the loop gain in L1? G1, G2, G3 minus H1. So you are going to get minus G2, G3 into H1. Can you tell me what is the gain of the loop L2, guys? The gain of the loop L2 is G3 into minus H2. So you are going to get minus G3 into H2. And what is the gain of the loop L3? You are going to get the gain of the loop L3 becomes you are going to get G4 into minus H3. You are going to get minus G4 into H3. And can you tell me what is the gain of the loop L4? If you try to see the gain of the loop L4, okay, what is the gain of the loop L4? G6 minus H1. You are going to get minus G6 into H1. Now, the second step is you need to identify two non-touching. Out of these four loops, which loops are non-touching? Can I say L1 and L2 are touching? Yes. L1 and L3, yes, touching at this point. What about L1 and L4 touching? L2 and L3 are also touching. L3 and L4, there are no two non-touching. So, what is the value of delta, guys? 1 minus L1 plus L2 plus L3 plus L4. Now, the interesting thing here is delta 1. How to calculate delta 1 here? So, for this forward path, whatever I have shown, for this forward path, you need to identify the loops which are not touching. Okay, for this forward path, you need to identify out of these four loops which are not touching, and with the help of those loops, you have to write delta. Are you following what I am conveying? Yes. Now, for this forward path between R of S to N1, Out of the 4 loops, I can say L1 is touching over here. L4 is also touching over here. What about L2 and L3, guys? They are not at all touching the forward path between these two nodes of our interest, right? So with the help of these two loops, if I write that corresponding delta 1, you are going to get 1 minus L2 plus L3. And is there any two non-touching out of these L2 and L3? They are touching. So the value of delta 1 becomes this one. This is how we need to calculate the ratio of N1 by R of S. Now the interesting thing what we have to do is, for suppose, okay, so this is about the brief idea about this particular question, right? So now I will give you one more previous gate question. Okay, I will give you one more previous gate question. So where you can easily understand what kind of mistake you are going to find. Okay, so let me try to see the next question so that you can able to feel about the exact idea about how to apply Mason's gain formula. Right. Now if we see this question, this is a previous gate question recently which was asked for, okay, 2 marks, okay, and nearly 80% of the students, they made a mistake for this particular question. What they have done is they have given this signal flow graph and ask you to simply determine the ratio of C of S by R of S. Ask you to simply determine what? C of S by R of S. Now for this question, for suppose if I blindly apply Mason's gain formula, what they have given is they have given the options in this fashion. They have given an option as G1, okay, divided by 1 plus H1 plus H2. This is first option what they have given. Option B, what they have given is G1 divided by 1 plus H1 into 1 plus H2. This is the second option what they have given. And third option is G1 divided by 1 plus H1 is the third option. And the last option is G1 divided by 1 plus H2. Let me try to solve. For suppose, if I directly apply Mason's gain formula over here. If I directly apply Mason's gain formula, what will happen? Can you tell me what will happen if I directly apply Mason's gain formula? Because most of the students in the exam, they never bother about the limitations of applying any kind of concept, right? For suppose if I blindly apply Mason's gain formula, I can start from R of S and see how many ways you can reach C of S. There should be unidirectional flow of signal and all the nodes you have to touch only once. So I can say this is my forward path. Can you tell me what is the gain of this forward path, guys? G1, P1 into some delta 1 divided by delta 1 minus. How many loops are there in this question? I can say this is one loop. Yes or no? This is one loop. I can say loop L1 and this is second loop L2. So if you observe here 1 minus loop gain. What is the gain of the first loop? L1 is minus H1. What is the gain of the second loop? Minus H2. And after that, the students even, okay, not bother about the two non-touching combinations. For suppose if you are not going to write two non-touching loops, the answer becomes G1 divided by 1 plus H1 plus H2. So this is the first option which is wrong actually, right? You need to even careful about two non-touching. For suppose, if you identify, I can see L1 and L2 both are non-touching. You need to multiply the product of those two non-touching combinations. Minus H1 into minus H2 becomes H1 into H2. And for this forward path, okay, whatever I have shown, this loop L1 and L2 both are touching at these positions, right? So this loop is touching at this position, this loop is touching at this position. There are no loops which are not touching, so you are going to get 1 minus 0. So if I do the simplification of this one, what you are going to get is G1 divided by 1 plus H1 into 1 plus H2. So which option you are going to get? Option B, which is again wrong. Why? Why it is wrong? If you blindly apply Mason's gain formula between the any two nodes in the given question, then definitely you will get a wrong answer. Because Mason states that the formula will be useful or applicable between output node to input node. Now, if you clearly focus on the given question, okay, this is the question. Can you tell me, can I say C of S is a output node or input node or mixed node? I can say C of S is a mixed node. Why C of S is mixed node in the question, guys? This is, I am saying as a mixed node. Why? Because it is having both incoming and outgoing. How many incoming and outgoing branches are there for this node C of S? I can say this is my incoming branch. If you sit here, I can say this is my incoming branch. What about this one? If you see, this is called as a self loop. What is the definition of self loop? The loop which is starting at a single node and which is terminating on the same node. Okay, the loop which is having a single node is called as a self loop. That means the loop will start from the same node and it will terminate on the same node. You won't get more than one node. Okay, so that means if you start from here, I am terminating on the same node. So this is called self loop. If you consider self loop, okay, so at this point, this is incoming branch. This is from here. If you see from here, I can see it is outgoing branch. Whereas if you see at this instant, this is called as incoming branch. So self loop will be splitted as one outgoing branch and one incoming branch. Are you following? So for this particular C of S node, I am having two incoming and one outgoing branch. So that is the reason I can treat it as a mixed node. Now if you consider this one, I can say this is R of S. R of S is also having from, if you sit here, this is outgoing branch, whereas this is outgoing, whereas this is incoming. So it is also having both incoming and outgoing. So R of S is also a mixed node. Okay. But previously I have given one statement that any mixed node can be converted as output node. That means, for suppose if I want to convert the C of S node as an output node, I am going to add one outgoing branch with unity gain. So I am going to convert here. I need to determine C of S by R of S. Yes or no? Here C of S is a mixed node, but anyway I can convert this mixed node as an output node. Yes or no, guys? But R of S in this example is also a mixed node. I cannot convert this mixed node as an input node. Any mixed node can be converted as output node, but not input node. Are you following what I am conveying? Right? So that is the reason I cannot directly apply Mason's gain formula. If you apply Mason's gain formula, it will be the wrong answer. Now, what is the correct way of solving this particular question? There are two methods I will tell you here. Okay, the first method is, have you understand? I hope you understand why this answer is wrong. I cannot directly apply Mason's gain formula between two mixed nodes. What? I cannot directly apply. Please make a note of that point. I cannot directly apply Mason's gain formula. Directly cannot. Okay, but we will see the procedure. I cannot directly apply Mason's gain formula between any two mixed nodes. Now, if you observe here, what we will do? Let me erase this whatever the stuff which we have discussed, so that we can concentrate on the diagram. Right. So this is a mixed node. Yes. Yeah. Yeah. So this is the diagram what they have given, right? So in order to solve this question, what I will do is, I will use two methods. Method one is node value concept. This is very simple. But if the diagram is very complicated, I cannot even apply node value concept. The definition of node value is, if I want to say, if this is a node, if I want to calculate the node value, you have to identify, okay, how many incoming branches are there for that particular node. You need to see the definition of node value is sum of all incoming signals, with corresponding branch gains. Sum of all incoming signals with corresponding branch gains is treated as node value. Now, for suppose if I am asking you, tell me what is the node value of C of S. Okay, how many incoming branches are there? Two, because self loop is treated as one incoming and one outgoing, right? So anyway, this is incoming. Can you tell me sum of all incoming signals with corresponding branch gains? This is incoming signal with gain G1. So you are going to get G1 into R of S. Sum of all incoming signals with corresponding branch gains. Multiplication of branch gains with the incoming signals. And this is also here, from here, this is also incoming signal. So what is the gain? Minus H2 into signal is again C of S. Now do the simplification so that you can able to get the value of C of S by R of S. Now if I take this second term to the left hand side, what you are going to get? C of S plus H2 into C of S is equal to G1 into R of S. Now take C of S as common and take the ratio of C of S by R of S. What is the answer you are going to get, guys? G1 divided by 1 plus H2 is the correct answer for this particular question. G1 divided by 1 plus H2. This is one method of signalizing. Now I will try to tell you one more method of solving the same question. Okay, so the other method, let me erase this one. So the correct answer is G1 divided by 1 plus H2. The second method what I would like to convey here is, for suppose, if at all, the observation what we are getting from this discussion is, here, if I want to apply Mason's gain formula, what I will do is, in order to get the same answer, I can see this is a self loop at input side, this is a self loop at output side. Yes, what I will do is, always neglect self loop. This is only observation, there is no standard proof. What I am saying is, always neglect self loop at input side. Neglect self loop at input side. For suppose if I neglect the self loop at input side, then the diagram becomes what you are going to get, guys. The diagram becomes, you are going to get, this is my R of S. After neglecting self loop, this is G1, this is minus H1, and this is C of S. Now I can comfortably apply Mason's gain formula, because our interest is to determine C of S by R of S, and always neglect self loop at input side. If I neglect self loop, this R of S becomes anyway input node you are going to get. Am I correct or not? Yes. Now if you apply Mason's gain formula, how many forward paths are there? Only G1. Okay, P1 into delta 1 divided by delta 1 minus. How many loops are there? Only one loop. What is the gain of that loop? Minus H1. And for this forward path, this loop is touching, you are going to get delta 1 equal to 1. So if you do the simplification, you are going to get, sorry, this is what is this gain? So this is minus H2, guys. So this is minus H2. You are going to get G1 divided by 1 plus H2 is the answer what I am going to get. Are you following? So I hope you understand this. I hope you understand this particular question. Let me finish these special cases with one more last example. Okay. So if you can able to solve this, you can able to understand the complete idea about Mason's gain formula. I will give you the summary later. So if you are taking this is C of S by R of S, I am asking you to determine C of S by R of S. Now if you observe here, in fact C of S is a output node. Good. This is my output node. Why I am saying this is output node? Because it is having only outgoing branch, sorry, incoming branches. What about R of S, guys? R of S is having both outgoing as well as incoming, so it is a mixed node. It is a mixed node. So I cannot convert this mixed node as an input node as we discussed. So I cannot directly apply Mason's gain formula. I cannot directly apply Mason's gain formula. So now what I have to do here? So previously in the previous question, what I have done is I have neglected the self loop at input side. But if you observe here, do you have any self loop here? You don't have a self loop. Self loop in the sense, the loop has to start from only one node and it has to terminate on the same node. The loop which consists of only a single node. But here this is a loop, but it consists of two nodes, right? So if I am trying to draw this, I can say a loop, but it is having two nodes at this point and at this point. So this is not treated as a self loop. So here there is no self loop. I cannot neglect. Now what is the procedure I have to follow here? Okay. So the better method is best method. There are two methods again. As I said, you can assign signal assign procedure. So that means here, as I said, you can use the node value concept. But applying node value concept in this kind of some complex or lengthy questions is very difficult. That is the reason, even though technically the next method is not correct, but in order to get the same answer, what I am doing is I am creating a dummy node. What I am doing? I am creating a dummy input node. Okay, let us assume that is X of S. This is my dummy input node for solving the question. But technically we cannot able to create this dummy input node theoretically. So and I am going to assign this gain of the branch as 1. Now in the question I know that my node input node, dummy input node is X of S. Now what I have to do, I need to determine C of S by R of S. So if I want to calculate C of S by R of S, what I will do is, here C of S is a output node and R of S is mixed node. What I will do is I will try to rewrite this given expression in terms of the input node of the system. What is the input node of the system, guys? Here we have created a dummy input node. What is that dummy input node? X of S. Now I can able to write this C of S by R of S as C of S divided by X of S. This is one term, whole divided by R of S divided by X of S. Yes or not? Right? If I write this in this fashion, X of S will get cancelled. I will lead to the same answer, C of S by R of S. Now, can I separately apply Mason's gain formula between C and X and R and X? Yes. Why? Because if you see here, C of S is output node. What about X of S? It is a dummy input node. I can apply Mason's gain formula between output to input. And what about R of S and X of S? R of S is mixed node and X of S is input node, dummy input node. Anyway, mixed node can be converted as output node, right? So I can apply even Mason's gain formula between these two things. Are you following what I am saying? So what I can able to do, C of S by X of S and R of S by X of S. First I will try to apply Mason's gain formula between C and X. And I can apply Mason's gain formula between R and X, so that I can able to get the corresponding answer. So take the ratio of these two things. What I will do, I will quickly solve. How many forward paths are there between C and X? One forward path, right? What is the gain of that forward path? You will have G1, G2, G3 into P1 into some delta 1 divided by delta. There is no need of writing delta, guys. I will tell you why. For a given system, delta will be remain same whether you are calculating between transfer function between two nodes C and X or R and X. Delta will be remain same even for this one. So what will happen? This delta will get cancelled. You are going to get only the numerator terms. So can you tell me for R of S by C of X, how many forward paths are there? Only one forward path. P1 into some delta 1. Right. Now, how many loops are there in the given system? I can say total there are 2 loops are there. This is my loop L1 and this is my loop L2. Now, for the first forward path, for the C of S by X of S, okay, G1, G2, G3, for this forward path, I can say loop L1 and L2 are touching. So, you will get 1 minus 0. For this, between R of S to X of S, this is the forward path. For this forward path, loop L1 is touching over here. What about loop L2 is not touching? So, you are going to get 1 minus loop L2. What is the gain? You are going to get minus G2 into H2. So, this is the answer for C by R. C by R. So you are going to get G1, G2, G3 divided by 1 plus G2 into H2. So that means whenever if I am asking you to determine the transfer function between denominator which consists of a mixed node, then what you have to do, you need to rewrite the given system in terms of available input node in the system. Okay. Here, if there is no available input node, then we have to create a dummy input node. What is the meaning of available input node? For suppose, if you are taking this particular question, if you are considering this particular question, Okay, here, for suppose if I am asking you, tell me what is N2 by N1. Please focus, all of you be alert. If I am asking you, tell me what is N2 by N1. What is N2, guys? Here in this question, this is N2, this is N1. I can say N2 is a input node or output node or mixed node. I can say N2 is a mixed node. What about N1, guys? N1 is, in this case, is also a mixed node. Can I directly apply Mason's gain formula? No. What I have to do? Since I cannot directly apply, always I can apply Mason's gain formula between output to input node. Right? Now, if you want to apply Mason's gain formula between two mixed nodes, what I have to do is, I can anyway convert my mixed node as an output node, but I cannot convert the denominator mixed node as an input node. You have to rewrite this expression in terms of available input node in the system. Is there any input node available in this given signal flow graph? Of course, there is R of S which is available in the system. Yes or no? So, I can rewrite this expression as N2 divided by R of S divided by N1 divided by R of S. Yes or no? I can separately apply Mason's gain formula between N2 by R of S and N1 by R of S. I can take the ratio of those two things in order to get the transfer function. So, the point you have to understand here is, whenever if I am asking you to tell me the transfer function in such a way that the denominator, if it consists of mixed node, then you have to rewrite that expression in terms of available input node in the system. Or else, if you don't have any input node available in the system, you have to create a dummy input node. Have you understand? So, the conclusions what I would like to say here is, the Mason's gain formula is directly applicable between output node to input node. I can directly apply. Second one, even I can directly apply between mixed node to input node. But I cannot directly apply the Mason's gain formula between output node to mixed node. Or I cannot directly apply Mason's gain formula between mixed node to mixed node. Okay. So that means the denominator must be input node. If the denominator is not input node, then what I can do, I cannot directly apply Mason's gain formula. If you find these kind of questions, whenever if they ask you to determine the transfer function between output node to mixed node or mixed node to mixed node, what I have to do? We need to rewrite this given expression in terms of available input node in the system. So for suppose if there is a available input node as R of S, I am going to rewrite this as output node by R of S. What is this R of S, guys? I will write that, and divided by mixed node by R of S. And here this R of S is what? Available. Okay, this is available input node. Available input node in the entire system. Available input node R of S. For suppose, okay, even here also what I have to do, I need to write this one as mixed node divided by R of S divided by, this is mixed node 1, mixed node 2, Mn1 divided by mixed node 2 divided by R of S. This is the way we have to rewrite the expression. Are you following what I am conveying? For suppose if there is no available input node as in the shown, you need to create a dummy input node. What you have to do? You need to create a dummy input node, and we have to rewrite the expression in terms of creating dummy input node. So this is about the brief idea about how to apply Mason's gain formula, because we have find so many gate questions where they have given the transfer function between output node to mixed node or between two mixed nodes, and they are directly asking the questions. I hope you have got a complete idea about the special cases of this Mason's gain formula. So this is how the VEDA Gate Academy is going to give the depth of the subject and all the possible special cases. So here the conclusion what I would like to say from this session is, the Mason's, you need to understand the limitation of Mason's gain formula. The Mason's gain formula limitation is, I cannot directly apply Mason's gain formula if the denominator is not an input node. That means if the denominator is a mixed node, then I cannot apply Mason's gain formula. For that, what is the procedure? This is the procedure what we have to discuss. So this is how you have to learn the subject. If you can able to go in depth under special cases and limitations of any concept, then you will never do any kind of mistakes and you won't get negative marking in the GATE exam. So this is how VEDA GATE faculty will be teaching throughout all the subjects, and I am giving 100% assurance that trust me, we are with you and you can able to crack any kind of technical competitive exam once if you listen the classes. Thank you. All the very best.